Okay, this is the example that says estimate the area under the graph x squared minus 3x plus 1 from x equals 3 to 8. And we are going to use n equals 5, the number of rectangles, using right, left endpoints, and then we would repeat that using midpoints. So as the graph of this function is increasing, if we draw that here, when you plug in 3, find f of 3, that would be 1. So 1, 2, 3, and then 1 is this point. And if you plug in 8, which is the other endpoint, you would get 41. So 8 and the number somewhere here as 41. We know that this function is increasing here. So when we want to divide it into 5 rectangles, we are going to use delta x. In here, b minus a over n, which is the main formula, will be 8 minus 3 over 5, which is 1. So starting the first point as x of 0, which is 3, the next point will be adding 1 to the previous one, which the formula says x of I equals the first one plus the multiples of delta x. In here, delta x is 1, so we're going to add 1 to the previous point. So we have 4. Next point will be 4 plus 1, which is 5. And the next one, 6, 7. And the last one, 8. For the first part, it is a good idea if we find f of these points here. So f of 3, if you plug in to the original function, you get 1. F of 4, you get 5. F of 5, you get 11. F of 6, you get 19. F of 7, you get 29. And f of 8 will be 41. Now, for the first part, we are going to find left endpoints. We are going to find the area using left endpoints. It means L sub 5. So according to the formula, that would be limit of the sigma. But in here, we are going to use rectangles. So it means that using delta x, these are the rectangles with a width 1. And when we are using left endpoint, we start from 3, next one 5, all the way to the, not the last one, the previous one, which is 7. So we're going to multiply delta x to all f of x of i's, but not the last one, because we're going to use left endpoint. So we know that delta x here is 1. So we would add f of 3, f of 4, all the way to f of 7. So L5 is delta x is just 1. We have 1 plus 5 plus 11 plus 19 plus 29, which will be 65 as left endpoint approximation. Next one is using the right endpoint, let's say R5, same formula, but this time we use the last one because we're going to use right endpoints, but we don't use the first one. So it will be starting f of 4, ending f of 8. And we know that delta x is 1 multiplied by the values of x sub i's, starting 4, ending 8. That would be 5 plus 11 plus 19 plus 29 plus 41, which will be 105 as the right approximation. The next part is about using midpoints. So between these two, let me fix this one. Okay, between the two of them, the first ones, we have 3 and 4. And the midpoint here will be 3.5. The midpoint here is 4.5. And also here 5.5. Next one, 6.5. Here, 7.5. So I'm going to find f of these points multiplied by delta x, and that would be approximation of m sub 5 here. We know that delta x is here, so we're going to find f of 3.5, f of 4.5, f of 5.5, 6.5, and 7.5. M sub 5 will be 1 as delta x, and if you plug in these numbers into the original function, you get 2.75 plus f of 4.5 will be 7.75, f of 5.5 will be 14.75, and f of 6.5 will be 23.75. And the last one, 34.75. Altogether, using calculator, you get 83.75. So which one appears to be the best estimate? So for the green lines, we use underestimating because we used left endpoint and this function is increasing. But for the next one, we used overestimating using right endpoints as you see here, and that would be overestimating. But using midpoints of these two, let's say here as here, these are the ones that we use somewhere between underestimating and overestimating. So this one seems to be the more accurate one because it will give us less overestimated or underestimated area comparing to true area.